Hello everyone, I'm Asanka Abeysinghe, CTO at WSO2. It's a pleasure to be back at API Days New York stage. So today I'm going to discuss about how you can convert your business as APIs, as well as how you can leverage abstractions to drive the experience economy. So I'll take you through this journey during next 20 minutes. So let's start with abstractions. So abstractions are everywhere. That's why I put it as it's like your morning coffee. So there are many abstractions, but out of these abstractions, I picked two real world examples. The first example is maps. So if you look at the maps, it's a nice way to explain abstractions because maps simplifying how we navigate from place A to place B. So it takes the burden out and it's simplifying that particular process by letting us know how we can find the shortest path as well as how we can find the quickest path and simplify that process. So that way, like we don't have to worry about talking to strangers, finding landmarks. All this complexity goes away when we are using a map for our navigation in our day-to-day life. The second example is coming from Gen X. It's not a Gen Z thing. So transistor radios. So when we grew up, we used to listen to music using transistor radios. And if you look at a transistor radio, you will see bunch of knobs. A knob to change the channel, one to tune the channel, and the third one to change the volume. But if you move the transistor radio and look at the backside of the equipment, you will see a complex circuit board. It contains with resistors, transistors, capacitors, all these electronics are there, and it built using these electronic equipments. So the front end or the interface that you using to tune the radio abstract that particular complexity that you see behind the radio and make it a very simple process for you to operate. So that is the second example I would like to take. Then these are physical abstractions that we see in our day-to-day life. But when it comes to software, there are a bunch of great abstractions that we can see. But few fundamentals there. The first fundamental is the encapsulation, and the second one is about the partitioning. So encapsulation, I explain in my transistor radio example as well. The front-end interface hiding all the complexity that we can see in the backend. So similarly, in software engineering, we have this concept called encapsulation that we hide the complex logic that we write inside our programs. So we call these things as modules, and inside the module, you have the complex logic and the functionality exposed from the module through operations. So if we bring this into the current context, we can treat APIs as operations and the services as modules. So you expose all the capabilities in the service through a API through the operation. So that is how encapsulation works. But when you are designing large systems, one module doesn't work. That's where you need to partition this problem. So partitioning comes with dividing a larger problem into multiple modules and treat it in different distributed logics that you can get a bigger capability out from the entire system. So there are many ways to divide these modules, and in the modern architecture principles, we use domain-driven design as a really good way to divide some of these capabilities. Then the domains can even go into subdomains, and then it comes to services, and you can use various service architecture patterns like microservices, and even some of the capabilities can be built using traditional services as well. So that is where the partitioning coming into the picture and hiding this complexity of larger systems. So there were many movements happen in the software industry. When it comes to abstractions, there were few milestones. The first thing is about abstract data types, or we call it as ADTs. That was introduced by Barbara Liskov. So she introduced all the abstract data types like queues, maps, and stacks, uh, kind of structures that we use inside our programs introduced by her. So that was a really good improvement in programming. So we don't have to worry about how we can put a value to a stack, how we can retrieve a value to a stack. All these things are inbuilt based on the programming language, and that was a great introduction to software engineering. The second great abstraction is relational databases, or RDBMS systems. So that was introduced by Edgar Cod. And what Edgar did, simplify the way you store data and you retrieve data. Storing data done using tables, columns, and rows, and retrieving data done through standard query language, or we call it as SQL. So that way you don't have to worry about how you store in the data, how you retrieve in the data. Using these fundamental principles, you can do that operation. So the code's invention is similar to a library system, that how you can find a specific chapter inside a book, that books are arranged into various rows, and then you can find a specific book based on the indexes, and inside that you can find the chapter with the data you need to read through. The same concept apply in relational database systems. So those were came at the early stage of software engineering. In the modern software engineering days, the best abstraction we can find is Kubernetes. So Kubernetes is simplifying the deployment of workloads, as well as the quality of services associated with the deployment, the security, reliability, um, then how you scale these workloads across the number of different clusters, and make sure that the deployment process and how you run these workloads in a production environment simplify using Kubernetes standards. So it is like a traffic controller. It's not just like a traffic controller in an intersection. It's like a traffic controller in a busy airport that controls all the traffic coming to the airport and going out from the airport, as well as manage it within the airport. So these are three nice abstractions that we can find in software engineering. So there are many architecture abstractions as well that we used when we are designing systems. So I took one architecture abstraction that I introduced in 2018 called cell-based architecture. So this is a solution that I identified to simplify the microservice architecture, because we identified when you run thousand of microservices, it creates this situation called Death Star, that you will not be able to identify who owns a microservice and what are the dependencies between microservices. So as a solution, I introduced this concept called cell-based architecture, that you can group microservices or any other component that you need to run as a workload in your system can group into a cell. So cell is the boundary and it's the architecture construct. So this controls the communication of your system by dividing the communication into northbound, southbound, eastbound, and westbound. So that way you have a clear way of identifying who communicates with what and what are the dependencies inside a cell as well. So this is linking to the team structure. So in modern software engineering, we used two pizza teams or autonomous teams to do the development. So cell creates a boundary for the team as well. Now you can associate one cell into a team, or one team can have many cells as well, but a team cannot, one cell cannot be owned by multiple teams. So that is one fundamental rule that I have incorporated in the cell-based architecture. So if you look at the enterprise design using cell-based architecture, it looks like this. You will see number of cells that based on the scope you can name them. In this example, you will see employee cells, order cell, customer cells, and then you will see applications coming at the top that consuming the capabilities exposed by these cells as well. So if you would like to get more information about the cell-based architecture, I have put the URL here. You can go there and read the entire specification. So it is released under Creative Commons 4.0. So feel free to contribute, provide feedback, and criticize. So we are happy to take your feedback. So those are the abstractions that coming on the software industry as foundational architecture principles. But when it comes to a business, the abstraction that you define for your business is a game changer, and it is creating a new way of looking at the problems and finding solutions, and it is creating a new mental model as well as a good understanding about your business. So let's take a look at what are these business abstractions. So before jumping to that, let's take a look at as technologies what we are doing. So you might be in an engineering team, you might be a project manager, or you might be an architect or a DevOps engineer. But end of the day, the tasks that you are doing inside these projects are associated to some kind of a digital experience. So you are creating digital experiences for your end users, and you are part of that. Every IT activity, every expenditure that you do are linked to these digital products that you build for your end users. And that is coming with the economy as well. So if we are look at the current economy, we are living in a experience economy at the moment. As an example, if you go and buy a coffee cup, the bulk of the money that you are paying for the experience that you get, not for the raw materials or the service that they provide. So as an example, if you go to a top end coffee shop, the Wi-Fi you get there, people you meet there, and the environment that you have to have a coffee and work is the experience you get, and they charge most to that particular experience that they provide. So experience are creating differentiators because every service provider is providing same kind of experiences. So how consumers are differentiating this particular experience and picking a vendor depending on the experience that they get. So as technologies who's building digital experiences, we have to keep it in mind and then make sure that we are giving the best digital experience for the end users when creating software in our projects. So I took this quote from a filmmaker. So what he said, the customer of the future are not asking for efficiency, they want experiences, happiness, and relationships. So I strike out of the future part because it's already happening. People who's consuming these digital experiences, they are looking for the same objective. And as technologies, I would like to repeat it again, we have to provide their expectations by giving great digital experiences. So software industry is like movie industry because it's a very creative industry. Since we are generating experiences, we have to be creative. As an example, you take an idea getting into production, and then you do a release and you get the feedback and come back to the idea process again and go through that particular life cycle. It's an iterative process. So similar to the movie industry, you have to be very creative when generating software. So that's where the business abstractions are coming, because if you have to be creative, you need a foundation. So if you have a good foundation, you can create digital experience rapidly without having any blocker. So we call it as a rapid application development. So let's look at the business abstractions. So there are three layers in the business abstractions. First one is the deployment abstractions, and top of that you have the domain abstractions, and the domain abstractions are coming under the business abstractions as well. So let's take one of these layers individually and take a look at in detail. So deployment abstractions looks like this. If you look at it, it's very complicated. So I took some of the examples from CNCF landscape as well as AWS landscape. If you look at it, there are a lot of options that we have when we are trying to build the deployment abstraction. So it is about CI/CD, DevOps, GitOps, SecOps, observability, multi-cloud. All these things are required when you build a deployment abstractions layer, and it takes a lot of time as well as you need special skills to build a great deployment abstraction layer. So once you have a good deployment abstraction layer, you can build the business abstractions on top of that. So that's where the services like microservices come into the picture. You write functions, APIs, events, data. All these things are coming on top of the business abstraction layer. And domain abstractions are basically how you partition your business abstractions and then divide it using domain driven design or any other principle that you use and make sure that it is properly distributed. As well as domain abstractions can apply for specific verticals, like if you are coming from healthcare, if you are coming from financial sector, you can use the domain abstractions to optimize your software to cater your target audience. So once you get these two abstractions or these three abstractions, deployments, business, and domain abstractions, you can start building applications on top of that. So once you build applications, those are becoming the channels that end users can access the digital experiences, and they will get a great experience out of these applications that you built. So the highlight here the platform engineering side or the deployment abstractions are common for every organization. Since it is common, you will not get any additional benefit as an organization other than the efficiency. But the differentiator comes from the business abstraction that you create, because those are unique for you. And what you have to do, focus on the business abstractions and build more and more of these components in this layer and start providing digital experiences for your end users. So the concept of an internal developer platform comes with that. The deployment abstractions in today's world, we call it as a the internal developer platform, but don't try to build it because it's really complicated and time consuming, as well as you need a special skill set. Try to buy it and start building a foundation and give room for your developers to build business abstractions on top of that. So that's where the API is coming to play a role here, because the deployment abstraction layer connected with APIs as well as the business abstraction layer completely glue with APIs. So APIs is the key communication layer, and entire the abstractions are working on top of APIs. So we need to pay attention. But APIs are becoming, API management is becoming a commodity now. So the fun part is about how you can consume the APIs and how you can build applications by consuming this API in your infrastructure. So this is a common view of how APIs are used in modern enterprises. You have your system of record layer. Around the system of record layer, you have domain APIs and domain services. And then if you need to augment the domain APIs, you can have experience APIs. Then you have these various channels: web apps, mobile apps, LLM, API products, workflows, so on and so forth, that can deliver these digital experiences to your end users. And users can be categorized into three buckets. B2E are the employees, B2C are your customers, and B2B are your partners that consuming your applications and the services. So this is a common view of enterprise and how APIs are coming and playing a role in this particular business architecture. So, as a technology provider, we are contributing to this concept. From the API management point of view, we have three offerings. One is a SaaS API management product called Choreo API Manager, and we are building an API platform for Kubernetes, a Kubernetes native API platform, and we have a traditional API manager that you can run in a cloud environment as well as in on-prem, like the traditional hypervisor-based virtual machines. To find more information about these products, you can go to our website, wso2.com, and get more details. In addition to that, I spoke about internal developer platform. So we provide the internal developer platform as well, that is called Choreo, and it contains the complete internal developer platform capabilities in a very cloud native manner, as well as you can get some sub functionalities like SaaS API management, iPaaS, DevOps platform, cloud native applications, and cloud native application development environment inside the internal developer platform. Again, if you are interested, you can go to this URL wso2.com/choreo and get more details, as well as you can sign up online since it's a SaaS product and try out the product without any issues. So let's step back and look at what we learned today. Abstractions are simplifying everything in the real world as well as inside our organizations, and the software industries like movie industry, and it is fueling the experience economy. And business abstractions are key because that is the unique set of capabilities that you are building to create differentiators, and API is the glue and changing everything inside these modern abstraction layers. So, some guidance from me based on working with large organizations and helping them in their digital transformation journey. First, to buy the internal developer platform, don't build it, because, as I repeatedly said, it takes a lot of time and effort. And build great business abstractions and provide digital experiences to your end users. And once you get the first two, then you just have to add developers. Once you have these great abstractions done, you can just add developers and start building these applications and rapidly deliver these capabilities to your end users. So if you need more information and connect with me, these are my details to connect. I frequently write in my blog called architect2architect.com, and then you can find all my authoring at muchrank.com, as well as you can email me at my email address, and you can connect me through LinkedIn, as well as feel free to follow me in Twitter as well. Thank you very much.